All right, everyone, how's it going? It is no fun in this place without you. I hope you guys are all having a good time at home. Week 2 here, and I feel like I'm going crazy, but that's all right. Here we go. So if you have struggled in any way with that previous lesson on working with radicals, so adding, subtracting, converting from mixed to entire radicals, please fire me an email so I can find a way to help you. It's really important you can understand that stuff. Otherwise, the rest of this stuff on solving, multiplying, dividing, rationalizing radicals is going to be really hard for you. So let's move on then. For today, we are taking a look at multiplying radicals. So multiplying radicals, you can do that when the indexes are the same. And all you need to do is simply multiply the coefficients together and multiply the radicands together. Okay. And this is pretty much the exact same way that we multiply polynomials, but now we're doing it with this root sign in there, right? So if I had a polynomial like 2x cubed times 5x squared, to multiply this polynomial together, I multiply my coefficients together. So 2 times 5 would be 10. And then x squared times x cubed would give me x to the power of 5. Okay. And the same thing is going to work here when we're multiplying radicals. We have to have the same index. From there, coefficients get multiplied, radicands get multiplied. So I'm just going to skip to b here because it follows this example. So 9 root 2 times 4 root 7. I would take the 9 and the 4, multiply those together. That gives me 36. And then I can take the 2 and the 4 together. That gives me 14. But that needs to remain underneath the radical sign. I can't simplify that any further because 14 isn't divisible by any perfect number of the index or isn't divisible by any perfect square. Nice part about pretty much most of this radical unit is if you can know how to use your calculator, you can always verify your answers on your calculator. So I'm just going to go do that. So 9 root 2. Oops. Sorry, I'm obsessed with brackets. Times by 4. Oops, as I forget my next bracket. 4 root 7 gives me 134.699 blah blah, some irrational number. Apparently, we just figured out that that's equal to 36 root 14. Okay, and so it worked. It means that process of multiplying the coefficients and multiplying the radicands together will give me a equivalent irrational number. All right, so let's look at another example here. So I'm just going to come back to A. So the cube root of 3 times the cube root of 3. Well, there's no coefficients here, or the coefficients are 1, and 1 times 1 is just 1. So all I do is multiply the 3's together, so that's 9, and times the cube root of 9. Okay, my index is not going to change. We don't multiply the index together, they just remain constant. And if I want to verify that on my calculator, I could also do that. All right, let's continue for C here. So 2 root 5 times negative root 15. Coefficients get multiplied together. So 2 times negative 1 is negative 2. And 5 times 15 is going to give me the square root of 75. So what I need to do is, this is not technically my final answer because I need to make sure I reduce my radicand as much as possible. So looking at 75, I know 75 is divisible by 25, and that would be 25 times 3 gives me 75. So the square root, and technically this is what I'm doing, right? The square root of 25 is 5, and the irrational number would just be stay underneath as root 3. And I would times up the coefficients together. So negative 2 times 5 is going to give me negative 10 root 3. And so there is that answer when I multiplied my from C together. We'll do the same thing for D. Multiply. Now, whether I have 2, 3, 4 terms, process is still going to be the same. So I'll take my coefficients, so 2 times 3 times 1, and multiply those together to give me 6. And then I could go multiply the radicands together, so 5x times 3 times 6x squared. So 5 times 3 times 6, so is going to give me 15 times 90. And x times x squared is x cubed. You could, or if you look at this, be like, oh, I can actually simplify that. If you want to do that, that's okay. Sometimes I find if I simplify initially, I have to simplify again later. So usually I won't simplify in my first step if I'm multiplying, unless it's a really ugly question, which I didn't think this one was too bad. Then what I would have to do is take this and simplify it, right? I want to see if I can simplify, that radicand. Well, 90 is for sure divisible by 9 times 10 because 9 is a perfect square. So that would be the square root of 9 times the square root of 10. So that would be 6 times 3. And that would be the square root of 10 left underneath. The other thing that I need to do is deal with this x cubed. And I can recognize that x cubed is equal to x squared times x, right? And I'm square rooting those. And the square root of x squared is gone. Like I could take that out. So that's going to come out as an x. And I would be left with 1x underneath. So the final answer here would be 18x square root of 10x. That was a weird box. You could always verify that answer by graphing it, right? I could graph this as y1, graph this as y2, and they should be the same graph. I can also substitute an arbitrary value in for x. Remember, if you're trying to substitute arbitrary values in for radicals, you should not use 0, don't use 1. Depending on the function, you don't want to use a negative number, so I would choose a number like 5 or 10, and hopefully that should make sure that those are equivalent. Verifying. All right, so that's basic multiplication, very similar to multiplication of polynomials. Multiply coefficients, radicands together, and then simplify. Now, we're really extending here into a little bit more difficult multiplication. So with that being said, we have to remember the rules for multiplying polynomials. So multiplying rules for polynomials include like distributive property, or what you could call FOIL, or whatever other strategy your Math 10 teacher looked at. And so I'm going to mostly use distributive property and FOIL. Maybe your teachers called them other things, but it's going to work the same. So whatever you use for polynomials, right? If I was going to multiply out 2x times x squared minus 4, well, all I would do is distributive property, multiply what's out of the brackets to everything inside. And the same thing here works for radicals. So 7 times the square root of 3, all times this. So I'm going to multiply this and this together. So if I want to write what's happening here, and I wouldn't usually write this step, but I'll just write it so we know what's happening. 7 root 3 is being multiplied by 5 root 5. And 7 root 3 is being multiplied by negative 6 root 3. So I would want to write then what happens after each of these has been multiplied. So 7 times 5 is 35. I multiply my coefficients together. And 5 times 3, or root 5 times 3 is root 15 when I multiply my radicands together. So 35 root 15. Then I'll do the same thing here. So 7 times 6 is a negative 42. And I'm multiplying radicands together. So 3 times 3 is the square root of 9. The thing to remember here is I want to simplify as much as I can. So I'll look at that 35 root 15, and 15 isn't divisible by any other perfect square. So I would leave that as 35 root 15. And when I look at this, 42 root 9, well, root 9 is actually equal to 3. So this is just negative 42 times 3, negative 126. And I could always verify that answer by putting this on my calculator, this on my calculator, and I should get the same answer. Next one, as we kind of move through, we start adding more variables into here. And we also have to remember exponent laws, not just how to multiply radicals or polynomials. So when I distribute a property, everything in front of the brackets goes to everything inside of the brackets. I'm taking 9, the cube root of 2, and multiplying it to the cube root of 4w and to 7 cube root of 28. So I'll do this first of all. So 9 times 1 is 9, and 2 times 4, so this would be the cube root of 2 times 4, which is 8, and w times w is w squared. Just in case you're not sure what happened there, right? I'm taking 9 cube root of 2w and timesing it by the cube root of 4w. And I'm taking 9 cube root of w and timesing it by 7 cube root of 28. So when I do that, multiply my coefficients together. So 9 times 1 is just 9. Cube root of 2w times 4w is going to give me 8w squared. And I'll do the same thing here. 9 times 7 is 63. So plus 63. And w times 28 is the cube root of, or sorry, times by 2. I missed my 2 here. Times by 2w times 28 is going to give me 56w. Once I have that, again, my step that I need to do is I can't leave it there. I need to simplify that radical as much as possible. So looking at each term individually, I can't add these, right, because I don't have the same radicand here. So I need to see if I can simplify each of these individually. So looking just at this to begin with, I know that the cube root of 8 is 2. So I actually be able to take the cube root of 8 and just say, well, this is 9 times 2 and times the cube root of w squared. So 9 times 2 is 18 cube root of w squared. Here, 56 isn't, is 56 a perfect cube root? No. But 56 can be divisible by 8. So this would be 8 times 7. So that would be the cube root of 8 can come out. So plus 63 times 2, cube root of 7w. So 63 times 2 is going to give me 127. 126. Sorry. Cube root of 7w. And so pretty ugly answer, but the final answer nonetheless. Okay. How many more am I going to do? Let's look at 2 or 3 more here. So the next one is root 8 plus 3 all to the power of 2. Now, what a lot of people forget, even when we're looking at, polynomial multiplication, is they'll multiply c out incorrectly. And the reason is they want to take this 2 and they want to do distributive property. Well, you can only do distributive property to exponents if it's a monomial. So really, this is saying this is 8 root 8 plus 3, or sorry, root 8 plus root 3, and there are 2 of those. So now we need to multiply out this set of binomials. And we would do that the same way that we do polynomial multiplication. So we could do FOIL or distributive property, whatever you want to call it. So first, root 8 times root 8 would give me root 64. Root 8 times 3 is going to give me the square root of 24. Root 3 times root 8, the square root of 24. And root 3 times root 3 is the square root of 9. And what's going to happen here is, if you already see it, that's great. But when I go root 8 times root 8, that actually just gives me a perfect square, right? It's saying root 8 and timesing it by itself. So that actually just gives me square root of 64, which is 8. So if you can kind of jump and just say, oh, that would be 8, I can do that. Same thing on my last, when I multiply out the last 2 terms in this binomial. This is root 3 times root 3, which is the square root of 9, which is just equivalent to 3. When I multiply equivalent terms by themselves that are radicals, I get rid of the radical and just end up with that number, right? So root 3 times root 3 is actually just 3. The other thing that I can do here is combine those as like terms, because that would be 2 root 24. if I want to add those together. My final answer, however, should be completed by actually simplifying. So if you wanted to simplify up here or down here, it doesn't matter. So 8 plus 3 is going to come together to give me 11. And 24 is divisible by the perfect squares of, or is divisible by 8, which isn't, sorry, a perfect square. Sorry, 4 and 6. So square root of 4 times the square root of 6, the 4 would come out as 2 times 2 root 6. So this is going to give me 11 plus 4 root 6. And that's my final answer. I can actually verify that, and I will, just to show that we did that correctly. Verify that on my calculator just to show that we multiplied outright. So the square root of 8 plus the square root of 3 all to the power of 2 gives me that as a decimal. And my answer here is, what is it? 11 plus 4, 11 should equal to 11 plus 4 times the square root of 6. And so those are identical irrational numbers. So I know that I multiplied out correctly. Okay. E is actually a really nice question if you can identify the shortcut. So I'm just going to go through it regularly, and then we'll, if you can see the shortcut, that's great. If not, I'll talk through it. So this is, root 8 minus 3 times root 8 plus 3. So I will FOIL that out. So root 8 times root 8, and like we had said previously, well, root 8 times root 8 is 64, or the square root of 64, which is just the square root of 8. And then we go 8 times root 3, so that's going to be a positive square root of 24. And negative root 3 times 8 is a negative root 24. And then root 3 times negative root 3. So when we said the same numbers that are being multiplied, that'd be the square root negative square root 9, which is a minus 3, right? Because this is equal to the square root of 64 and the square root of 9, but I'm just cutting a step out. So what you can see happens here is this is a positive root 24 and a negative root 24. So those are just gone, right? They cancel each other out, like 1 minus 1. 8 minus 3 is going to give me 5. So that should be my final answer. Now, if you notice what happens here, or what this question is, if you remember factoring, that is what we would call a difference of squares, or what they are called conjugate terms. The nice part about multiplying out conjugate terms, or factoring difference of squares, right, is when you multiply out, let's say I do FOIL, you actually don't have to multiply out the inside terms and the outside terms, just the first and last, because the two middle terms when you're multiplying here will cancel each other out, right? This and this cancel each other out, so I don't need to keep multiplying there. So I just have to go the first and the last if I want to kind of have a shortcut. All right, one more quick question, and then we'll be done. All right, so pretty similar here. I'm just going to multiply out. So 8 root 2 times 9 root 5. So 8 times 9 is 72. And root 2 times root 5 is root 10. So outside terms, 8 root 2 times 6 root 10. So 8 times 6 is a positive 48. And root 2 times root 10 is 20. Negative 5 times 9 root 5 is going to give me a negative 45 root 5. And negative 5 times 6 root 10 is a negative 30 root 10. So quite a few terms there. And we want to see if we can simplify as much as possible. So right now I can actually identify two like terms, right? 72 root 10 and negative 30 root 10. They have the same index, same radicand. So all I need to do is subtract those two coefficients. So those are going to come together to give me negative 42 root 10. And the rest of this, I need to try and simplify. So So I need to somehow maybe simplify those. Maybe they just remain as is, but let's see. This here has a radicand of 5, so I either need to get this to be a 10 or a 5. Because if it's a 10, then I could combine it here to simplify. And so I know off the top of my head, 20 can be put into the factors of 4 times 10. So root 4 times root 5. So this is going to become plus 48 times the square root of 2 times 5 minus 45 root 5. So I'll just bring this term down, which I'm not touching, and simplify this. So 48 times 2 is going to give me 96 root 5 minus 45 root 5. So I can combine those together as like terms to get 96 minus 45 is 51 root 5. And this term just stays as is. And that would be a positive number. Okay, there's my final answer. Again, I should be able to put this on my calculator and this on my calculator, and I'm going to get the exact same decimal. And that's how I know that I've done that right. I'm not going to go through F. If you're curious to see all the work for F, just go take a look at the scanned copy of my note package. It's a little bit more difficult question there for you. Okay, so then we are looking at homework 2, which is on multiplying radicals. Again, like I said for the last lesson, I wouldn't suggest that you do all of those questions. I would just suggest that you, try 2 or 3, maybe 4. And if you're struggling, then you probably need to do more or need to contact me and I can try and help you in whatever way possible. Please make sure you're not just doing like the 4 or 5 easiest questions. Do 2 from the top, 2 from the middle, 2 from the bottom. Also, make sure you're trying some questions that do have variables in there as well, because those would be those standard of excellence questions. Okay. All right. Any questions? Please just comment them in the section or fire me an email. Thank you.